Yes. Good evening, dear students. Okay, so in the last class, we have completed about aldehydes and ketones, okay? And we had started with carboxylic acid. So what are carboxylic acid? So what we have discussed about carboxylic acid, students? So carboxylic acid, okay, so how it is represented? The group carboxylic acids, okay, COH, right? So the carbon, that is a carbon compounds, okay, containing a carboxyl function group. So you have a carboxyl functional group, and such compounds are called as a carboxylic acid. Okay, so what is it consists of? It consists of a hydroxy group attached to a carboxyl group, right? To a carbonyl group, your what it is, a hydroxy group is attached in a carboxyl group. Okay, so hence it is called as a carboxyl. Okay, so to a carbonyl, what is attached? Your hydroxy group is attached. Okay, so we have discussed these things. So carboxylic acid, they are of two types, aliphatic and aromatic. Aliphatic means what? To the carboxylic group, the alkyl chain or alkyl group is attached. Okay, and aromatic means the carboxylic group is attached to a ring system, that is to a benzene. Okay, aromatic ring, benzene compound. Okay, so it can be aliphatic or it can be aromatic. Okay, then we have seen that the structure, then also then we have seen the nomenclature. Okay, then we have discussed the nomenclature, how to write the common names. So most of the carboxylic acids, okay, they are given the common name, okay, by because as they are naturally occurring. Okay, so all the names are come for the carboxylic acid as they are naturally occurring. Okay, so they have got the common name from as the occurrence, okay, from the natural sources. So these are some of the examples like formic acid, acetic acid, and butyric acid. Okay, then we have seen IUPAC system. Okay, IUPAC system. So aliphatic carboxylic acids are named by replacing the ending, okay, E in the name of the corresponding alkane with oic acid. So this also we have discussed. So whenever suppose I have methane, suppose I have ethane. Okay, so what we are going to do, we are going to replace this E. Okay, we are going to replace with E with a oic acid. Okay, OIC. So what will be the name, students? It will be ETAN. Okay, OIC, ethanoic acid. So the name is ethanoic acid. Okay, the name is ethanoic acid. So like this. So in IUPAC system, you are changing the end name, that is a suffix E with oic acid. Okay, so these things you have to remember. Then we have seen the priority series. Okay, so if any other functional group is present along with the carboxylic group, then the group gets the lesser priority and it can be used as a prefix. Prefix means it can the word, okay, whatever the word root you write, that you have to write as a prefix, the word before you start, okay, naming. So first you have to name that, and then your carboxyl group, it should get the lowest. Okay, so it should get the lowest numbering. And then when you see your this, okay, other than your what is that, sulfonic acid, so only sulfonic acid will have the higher priority. Okay, then your carboxylic group, and it can be used as suffix. Suffix means a word which is written at the end. Okay, then we have seen some of the examples, okay, how to name the compounds. Then we have seen the structure of compound, right? Structure of the carboxyl group. So when we see the structure of carboxyl group, okay, so I said that what? So this is the structure of carboxylic group. Okay, so here what you can see, that the carbon, okay, the carbonyl carbon is sp2 hybridized. Okay, it is sp2 hybridized. Then your oxygen is also sp2 hybridized. Okay, because it is associated with a double bond. This oxygen is sp3 hybridized. Okay, now you know how to write the hybridization. Okay, so here the bond angle which is made by the carbon CO bond here. Okay, it is planar. Okay, and the bond angle is 120 degree. Okay, it is 120 degree. And you can see the resonance structures also. Okay, so from this resonance structures are also given of the your what carboxyl group. So right like this we write the okay, and here what you can see the carboxyl carbon. Okay, this is less electrophile. Okay, it is less electrophilic than your carbonyl carbon. Okay, you can see that from this resonating structure. So this is the all about your structure of carboxylic group. Then we had started with the methods of preparation. Okay, then we had started with the methods of preparation. So these were the two methods which we have seen. First one was by for oxidation. Okay, from primary alcohols and aldehydes. So what we are doing, we are converting the primary alcohols to carboxylic acid, and aldehyde also on oxidation is converted into your carboxylic acid. Okay, so these are some of the oxidizing agent which we can use. Okay, potassium permanganate, potassium dichromate. Okay, in acidic medium. So these things we have used. So chromic acid, pyridine, chlorochromate, PCC. Okay, Jones reagent. What is Jones reagent? It is chromic acid plus sulfuric acid. Okay, in acetone. That is your Jones this. So these things also we have seen. Then next also from alkyl benzenes. Okay, from alkyl benzenes. So what we are doing here? We are oxidizing the side chain. So which is the side chain? Your methyl group. Oh, okay, let the irrespective of whatever the length of the side chain will be. So the side chain, whatever is present on the benzene ring, okay, it is going to get oxidized. So what we are doing here? So here you are having this is a toluene. So we are treating it with KMNO4 in the presence of KOH. Okay, KOH is a strong base. Okay, potassium hydroxide. We are going to heat it. What I am going to get here, what I am going to get, I am going to get a potassium benzoate. Okay, I am going to get a potassium benzoate. This potassium benzoate, what I am going to do further, I am going to undergo acid hydrolysis. It will undergo acid hydrolysis. So what will happen here? It will wash out, okay, your potassium salt, and you are going to get a benzoic acid. You're going to get what? Benzoic acid. Okay, so this is all about your toluene. So irrespective of whatever the how much ever the carbon atoms, okay, so it will get oxidized to what? It is going to get oxidized to carboxyl group. Okay, carboxylic group. Understood? Okay, so aromatic carboxylic acids. Okay, they can be prepared from this type of oxidation from alkyl benzenes. Okay, so you can use either chromic acid, or you can use acidic or alkaline potassium permanganate. So you can use this reagent. So here also we have taken one more. Okay, so N-propyl benzene. So one more we have, that is N-propyl benzene. Okay, N-propyl benzene. So I am going to N-propyl benzene in the presence of KMNO4 and KOH. Okay, we are going to heat it. I am going to get what? Potassium benzoate, potassium benzoate. Okay, further again acid hydrolysis to give you benzoic acid. Okay, to give you benzoic acid. So another oxidation reaction from alkyl benzene. Yes. Okay. Next, we are going to see from nitriles and amides. From nitriles and amides. Okay. So nitriles, what do you mean by nitriles, students? Cyanides. Okay, that is CN bond. So RCN is your what? It is a RCN is what? It is a nitrile. We call it as nitrile, or we call it as cyanide. Okay. So it is a nitrile or a cyanide group. So what we are going to do? So nitriles or cyanide, okay, they are going to undergo or we are going to hydrolyze them. Okay, in the presence of water, hydrolyze. Okay, we are in the hydrolysis. So in the presence of water, it is going to get hydrolyzed to what? To amides. Okay, and then to acids. Okay, and we are going to use any H plus or OH minus as the catalyst. So what we are doing? So nitriles, we are going to hydrolyze. Okay, we are going to add water. Okay, and we are going to get what? Amides. We are going to get amides. This amides on further reacting with in the presence of any acid or a base, I'm going to get what? Carboxylic acid. Okay, so this is the reaction. So amides is nothing but double bond O NH2. So I'll write the steps again. So I'm going to get, this is a cyanide. Okay, in the presence of, we are undergoing hydrolysis. Okay, so I'm going to get amide, C double bond O NH2. Okay, then what I'm going to get further, in the presence of H plus or OH minus. Okay, we are going to heat it. We are going to heat it. What I'm going to get? RCOOH. Okay, so or and NH3 in the presence of ammonia. So this is the what nitriles. Okay, they are hydrolyzed to amides and then to acids. So these are the steps. Okay, where we are hydrolyzing the nitriles. So one more reaction. Okay, so benzamide. So it is a benzamide. Okay, so benzamide again reacted with any acid or base. Okay, heated. So you are going to get what? Carboxylic acid. So here directly the step is from here. Okay, so directly they are not converted into nitrites. Directly they have taken the amide formation, benzamide. So this benzamide, when you treat it with in the presence of acid or base as catalyst, I am going to get what? Benzoic acid. I am going to get a benzoic acid. Is it clear? Yes, okay. Let me give you one more example. CH3CN. What is the name? Can anybody tell me what is the name? So two carbons are there, right? So it is ethane nitrile. Okay, it is ethane nitrile. So again, in the presence of your H plus and OH minus, okay, it will undergo hydrolysis to give you what? CH3, C double bond O, NH2. Okay, I'm going to get an acetamide. Okay, this acetamide further in the presence of the what catalyst. Okay, that is acid or a base. I am going to get what? CH3 COH plus NH3. I am going to get a acetic acid. I am going to get acetic acid. So this is a reaction. Understood? Okay. So we have seen three examples, how to convert or how to hydrolyze the nitriles to amides and then to acids. Okay. Next is from Grignard reagent. So what is a Grignard reagent? So already we have discussed what is Grignard reagent. So organometallic compound. Okay. Organometallic compound are called as what? They are called as the Grignard reagent. And how they are represented? RMGX. Okay, RMGX. So organometallic compounds are called as the Grignard reagent, and how they are written? They are written as RMGX. Okay, organometallic compounds are called as the Grignard reagent, and they are represented as RMGX. Okay, so Grignard reagent, we are going to react it with carbon dioxide. Carbon dioxide is also called as the dry ice. Okay, dry ice. So we are going to react the Grignard reagent with the dry ice. Okay, so we are going to react it with dry ice in the presence of ether. Okay, we are going to use a solvent that is dry ether. Okay, I am going to get what? I am going to get an intermediate. Okay, something like salt. So this is a like a salt of carboxylic acid. Further, which will undergo acid hydrolysis. Okay, on acid hydrolysis will give you what? Will give you a carboxylic acid. Will give you a carboxylic acid. So this is a salt of carboxylic acid. Okay, on acid hydrolysis will give you carboxylic acid. Understood? So what we are doing, Grignard reagent, we are going to heat it with carbon dioxide, that is dry ice. Okay. And what we are going to get? We are going to get salt of carboxylic acid. Further on acid hydrolysis will give you carboxylic acid. Okay. So this is the important reaction. So from Grignard reagent, mark is very, very important. Mark it as very, very important. So Grignard reagent is an important question, is a must ask question. Is it clear? Okay. So let me give you example now. I hope you can do it. Yes. Yes. So let me give you example. So our example is, okay. So let me take, yes. Okay. So just a second. Hmm. I hope you can see the screen. Yeah. Yes. Okay. So the example is so I'll take what R. I'll take it as methyl. So methyl magnesium X I'll take as I. So it is what methyl magnesium iodide. So methyl magnesium iodide. Okay, methyl magnesium iodide. React it with what? React it with dry ice. Okay, in the presence of dry ether. Okay, in the presence of dry ether, what I'm going to get? CH3, C double bond O and Mgi. Okay, O and Mgi. Then this will undergo acid hydrolysis further to give you what? CH3, C double bond OH plus Mgi and OH. Okay, so I'm going to get acetic acid. I'm going to get acetic acid. So these are the steps. So methyl magnesium iodide, when it reacts with the dry ice, okay, I'm going to get dry ether. Okay, so I'm going to get a salt of carboxylate salt, right? This is a salt of carboxylate, which on further acid hydrolysis will give the acetic acid. Okay, very, very important. Grignard reagent is a very, very important question. Yes. Okay, let us go for the next one. So from acyl halides and anhydrides. From acyl halides and anhydrides. Okay. Okay. So from acyl halides and anhydrides. So acyl halide, how do you represent acyl halide, students? How do you represent acyl halides? We have seen this already. Okay. So R C double bond O X. So this is acyl halide and anhydride is R C double bond O R C double bond O. So this is acid anhydride. So this is acid chloride. This is or acid what do you call it? Acyl halides. And this is your acyl halide and this is your acetic anhydride. Acetic anhydride. Okay. So now what we are going to do? So acid, you can take acid chloride, RC double bond O, Cl, react it with water, what I'm going to get? I'm going to get RCOH plus HCl. Okay. And acetic anhydride, RC double bond O, RC double bond O. Okay, acetic anhydride, again react with water. You are going to get what? 2 times RCOH. So 2 molecules of carboxylic acid is formed. Is it clear? So from acyl halides and from acid anhydride. Okay. So let us go further. I'll tell you. Okay. So let me take an example. So let me take R is as CH3. So CH3, C double bond O, Cl. Okay. React it with water. React it with water. So what is the name? It is a acetyl chloride. Okay. And what I'm going to get? I'm going to get CH3, COOH plus HCl. Okay. I'm going to get acetic acid. Okay. Then one more example. C6H5. Okay. C double bond O. C6H5. C double bond O. Okay. Again, in the presence of water, what I'm going to get? I'm going to get C6H5 COOH. That is 2 molecules. Okay, that is 2 molecules of benzoic acid. It is a benzoic acid. Okay, yes. So, 2 examples we have seen acyl chloride and another is acetic anhydride. Okay, so this is C6H5, how it is written? C double bond O. Okay, So further reacting it with water. So this is, if I give you another example. So one is benzyl, another is a methyl group. So what will be the name? It will be benzoic benzoic ethanoic anhydride. Okay. So this on further H2O. So what will happen? So I'm going to get C6H5COH. Another is CH3COH. Okay. So I'm going to get a mixture of acid. One will be a benzoic acid, another will be acetic acid. Understood? So always this acid chlorides, they undergo base hydrolysis and they'll give this carboxylate ion formation. Okay, which on further acidification will give you the carboxylic acid. Okay, so this is the reaction. Next, we are going to go for esters. Okay, esters. So what you can see in esters, so acid hydrolysis of esters. Okay, acid hydrolysis is undergoing of the esters and it will directly give you what? Carboxylic acid. Okay, while if you undergo base hydrolysis, if it undergoes, it will show you carboxylate ion. Okay, carboxylate ion, which on further acidification, you are going to get a carboxylic acid. So if I give you a general equation, so RCOO R dash plus H2O in the presence of H, I'm going to get what? RCOH plus H plus. Okay, so I'm going to get a carboxylic acid. Okay, so I'm going to get what? So this is the ester. So esters, I'm going to do the reaction, okay, and I'm going to get carboxylic acid. So acid hydrolysis of esters will directly give you what? Carboxylic acid. Okay, and while base, if you do a base hydrolysis, then it will give you carboxylate ion. Okay, and further, which on acidification you can get the carboxylic acid. Now again one example, CH3, CH2, CH2, C2O, C2H5. So this is plus water. Okay, so what I'm going to get now? What I'm going to get? I'm going to get CH3, CH2, CH2, and COH. And there is C2H5, OH, ethyl alcohol. So I'm going to get one ethyl alcohol. Another is 1, 2, 3, 4. So butanoic acid. Okay, so these are the reactions. So one more we'll see with respect to aromatic compound. COO, C2H5 plus H2O in the presence of H plus. So now here you tell me what will be the answer. The name of this compound is what? Ethyl benzoate. Okay, ethyl benzoate. React it with water. I'm going to get benzoic acid. Okay, benzoic acid plus ethyl alcohol. Okay, so these are the reactions from esters. Okay, these are the reactions from esters. Is it clear? Okay. So next we are going to see the physical properties. Physical properties means how they appear. Okay, okay, how they are appear to be. So aliphatic, this when you see the physical state. So aliphatic carboxylic acids up to the 9 carbon atoms. Okay, they are colorless liquid. Up to 9 carbon atom, it is a colorless liquid. Okay, and then at a room temperature with unpleasant odor. So the smell is also not good. It is a bad smell. Unpleasant means bad smell. Okay, and higher members are wax like solids. Okay, and they are odorless. Okay, they have some smell, some quite of smell is there, but it is not bad. Okay, not too good. It is quite okay. There is no this. So aliphatic carboxylic acid, there are 9 atoms and they are colorless. Okay, and they have unpleasant odor. The higher acids are wax like solids and are practically colorless. Okay. Then boiling point, when we discuss about boiling point, carboxylic acids are having the highest boiling point. Okay, why? Because of the strong intermolecular hydrogen bonding. So most of that, because of that, most of the carboxylic acid, they are in the form of dimer. Okay, in the form of dimer. Okay, in the vapor phase as well as in the aprotic solvent. Okay, aprotic solvent. So this is about the boiling point. So boiling point, it is highest in carboxylic acid. Okay. Next is solubility. When we talk about solubility, aliphatic carboxylic acid, okay, up to the 4 carbon atoms, they are miscible in water. Miscible means they are soluble in water. What is the reason? Because they are having the tendency to form the hydrogen bond with water. And what happens to solubility? Solubility will decrease with the increase in number of carbon atom. Okay, higher carboxylic acids are insoluble in water. What is the reason? Due to increased hydrophobic interaction of hydrocarbon part. Okay, so benzoic acid is the simplest aromatic carboxylic acid and is nearly insoluble in cold water. And carboxylic acid, they are soluble in less polar organic solvents like your benzene, ether, alcohol, and chloroform. So what you have to remember, the aliphatic carboxylic acid up to 4 carbon atoms, they are miscible. They are soluble in water, but why? Because they can form hydrogen bonding with the water. As the solubility decreases with the increase in the number of carbon atom, the higher the carboxylic acids, it is insoluble. Higher carboxylic acids are insoluble in water, but they are soluble in the organic solvents. Okay. Yes. Next, we are going to see the chemical. Yes, next we are going to see the chemical reactions of carboxylic acid. Next, we are going to see the chemical reactions of carboxylic acid. So here, first we are going to see the reactions, okay, involving the cleavage of OH bond. Okay, so C double bond OH. So first we are going to see the reactions wherein this cleavage takes place. Okay, first is the acidity. First is the acidity. Okay, how they react with metal and metal like compounds. So carboxylic acid, when they react with the active metals like sodium, potassium, and it gives hydrogen gases liberated. So it is going to form the potassium salt here. So carboxylic acid is there. It is reacting with a active metal like sodium. We are going to get carboxylate salt. Okay, we are going to get carboxylate salt with the liberation of hydrogen gas. Then carboxylic acid, they react with alkali, which is the strong alkali. It is NaOH and KOH. Okay. You are going to get the sodium carboxylate. You are going to get sodium carboxylate plus water. Then carboxylic acid reacts with weaker as bases like sodium carbonate, sodium bicarbonate to form salt and carbon dioxide is evolved. So you can see carboxylic acid, it reacts with the bases like your NaHCO3, sodium bicarbonate. Okay, you're going to get again sodium carboxylate plus NO2 plus that is water plus carbon dioxide. So you're going to get the sodium salt of carboxylate plus water plus carbon dioxide. Is it clear? So this was about the acidity. Okay, this is about the acidity. So carboxylic acid, they dissolve, okay, in water, and it gives a resonance stabilized carboxylate anions and hydrogen ion. So when it stabilizes or when it dissolves in water, you are going to get a carboxylate ion. So the resonance of the carboxylate ion is as follows. It is given below. See, just go through. Yes. Okay. So So from equilibrium, okay, so this is not so important. So you can see from equilibrium constant, we have taken for the reaction. Okay, from this we get to know that pKa is equals to minus log of 10 Ka. So higher Ka value, stronger is the acid. So you have to remember this. If the Ka value is more, then stronger will be the acid. If higher the pK value, weaker is the acid. K is different, pK is different. Okay. Then strong acid, pKa should be less than 1. For moderately strong acid, 5 is greater than pKa is greater than 1. For weak acid, 15 is greater than pKa, which is less than 5. For extremely weak acid, pKa is greater than 15. Okay. So these things you have to remember. Okay. So next we will see what is the effect of substituents on the acidity, okay, of the carboxylic group. So if electron withdrawing group is attached to the R chain in carboxylic group, then acidity of carboxylic acid increases. Okay, so if there is a electron withdrawing group, so what does electron withdrawing group does? It withdraws the electron, okay, towards itself. So electron withdrawing group, whenever such electron withdrawing group is present, so what it does, it increases the acidity. What it does, it increases the acidity of carboxylic acid. And thus what it will do, it will stabilize the carboxylate ion. So what you can see according to the resonance structures here. So when it is, so here you can see, okay, in the resonating structures. So when an electron withdrawing group is attached, okay, next to a carboxylic group. So what it is doing, it withdraws electron towards itself. As a result, what will happen? We are saying that carboxylic acid, the acidity increases. Okay, and how it increases? By stabilizing this carboxylate ion. Okay, through this delocalization of negative charge. So there is a negative charge which is delocalizing, okay, around this carboxylate ion. Okay, so and this is like minus I effect. That is your inductive effect because of the resonance, or you can say the inductive effect. So what is the case one? If we are seeing the case one, so acidity of carboxylic acid, it depends on which electron withdrawing group is attached to the COH. So increase in acidity of acid is in order. So this is the order, okay. So based on which group is there. So if you have CF3, then acidity will be more. If you have phenyl, the acidity will be less. So it increases in this order, okay. Phenyl, then iodide, bromide, chloride, fluoride, cyanide, nitro, and CF3. Okay, so this is the greater the electron withdrawing strength. Okay, you can see what will happen. So stronger will be the your acidity, okay, of the acids. So this is the effect of you can see this is the effect of various groups, okay, and this is the increase of the order of acidity. So this is the increase. So and down, okay, so when you see this compound, okay, below, so what you can see, arrange the following acid in increasing order of their strength. Okay, so when you want to what you when you want to arrange them. Okay, when you want to arrange them, CH3, CH2, CHNO2, this. So which is more increasing, right? So when you see, so nitro is here, iodo is there, then fluoro is here, and here is a phenyl group. So first will be your phenyl group. Okay, first will be your phenyl group. So fourth will come first, and then will be your iodo group. Second will come first. Okay, and then will be your what? Fluoro, third one, and then will be your nitro. So like this, the order of this will increase. Okay, acidity will increase based on the what group has been attached. Okay, which electron withdrawing group is attached. So you need to know this. Okay, this how the which are the different this. Then second case, acidity of carboxylic acid depends upon number of electron withdrawing group attached to the carbon chain. So it depends on how many electron withdrawing group is attached. So number of electron withdrawing group increases, acidity of acid also increases. So as the number of electron withdrawing group increases, acidity of the acid also will increase. So here are a few examples. So here how many are there? Here 3 electron withdrawing group is there. Here 1, here 2, and here there are no. So how you can arrange the increasing order? So first is the 4, because there is no electron withdrawing group. Then will be your second, then will be your third, and then will be your first. So this is the order. So as the number of electron withdrawing group increases, acidity also increases. So one has more electron withdrawing group, so the acidity will be highest here, and here it will be lowest. Okay. So electron withdrawing group has the lowest, and here it is highest. Okay, next. Acidity of carboxylic acid, it depends on what? Okay, it depends on position of electron withdrawing group in carbon chain. Okay, so when you see the arrangement, okay, so when you see the arrange the following acids into their increasing order of acidic strength. So acidity of carboxylic acid depends on what? It also depends on the position. Okay, it has to depend on the position of this. Now here position, so here is the position. Okay, so we are, so there is cyano group. Okay, there is cyanide group. So we have to see. Okay, arrange the following acids into the increasing order of acidic strength. Okay, here it depends on what I said. It depends on the position of the group. Okay, position of the electron withdrawing group. Okay. Okay, so here we are. So you can see the different groups, okay, how it is arranged. So as the distance, okay, as the distance of the electron withdrawing group increases from the COH, so you have to see the distance between the electron withdrawing group and the COH here. Okay, for this third case, acidity of carboxylic acid, it depends upon the position of electron withdrawing group in carbon chain. So you have to see the position of the electron withdrawing group and the carboxylic group. So as the distance, okay, as the distance of the electron withdrawing group increases from the COH group, then its electron withdrawing tendency decreases. Okay. So now where is the highest? It is highest here. So here 1, 2 carbon, here 3. So third is the least. Okay, third is the least. Then is your second. Then is your fourth. And then is your first. So first has the highest what acidity. Okay, the acidity of the, or it is having the acidic strength. Okay, so as the distance between the electron withdrawing group and the carboxyl group increases, the acidic strength also decreases. Okay, next point, if electron withdrawing group is attached to R chain in carboxylic group, then acidity of carboxylic acid decreases. Groups like your R, okay, alkyl group or alkoxy group. Now arrange it. So here, so depending upon the alkoxy or the this group, so here this, so here and okay. So so if the electron withdrawing group is attached, okay, to R group, attached to R chain in carboxylic group, then acidity of the carboxylic acid decreases. Okay, so how it will be now here? Yes, how we'll explain it here? Yes, how will be how we will explain it here? So effect of the electron withdrawing group. So is attached to the R group, then acidity decreases. Okay, now here what you can see, here. Okay, so electron withdrawing donating capacity. Okay, so here when you have okay, so this your what is this? Propanoic acid. So propanoic acid will be having the least. Okay, propanoic acid will have the least. Then will be your this one. Okay, so first will be a fourth one, then will be second one, then will be your third one, and then will be your first one. Okay, so the highest will be where? So highest will be in your one and lowest will be in your four. Okay. So this is the increase in acidic strength. Okay, so these all things you have to remember, all these different cases what we have discussed. Okay, next we will see the formation of anhydride. Next we are going to see the formation of anhydride. Okay, so here carboxylic acids on heating with mineral acids. Okay, carboxylic acid, when you heat it with mineral acid, such as your sulfuric acid, okay, or P2O5, it gives you corresponding anhydride. Anhydride means, so I'm going to get your carboxylic acids are there, so there will be loss of water molecule. Okay, I'm going to get a anhydride. I'm going to get what? Anhydride. So acetic anhydride is formed here. Okay, so corresponding anhydrides are formed. Then esterification reactions occurs between alcohol and a carboxylic acid. So whenever carboxylic acid and alcohol reacts in the presence of any acid like concentrated H2SO4, you get a ester. Okay, so these reactions are called as esterification reaction. So esterification reaction, what it forms, esters and water is formed. Okay. Then reaction with PCl5, PCl3 and thionyl chloride. So the hydroxyl group of carboxylic acid behaves like that of alcohol and is easily replaced by chlorine atom on treating with PCl5, PCl3 and thionyl chloride. So this is your carboxylic acid reacted with phosphorus pentachloride. What will happen? OH will be replaced by Cl, POCl3 plus HCl. Similarly, okay, alcohol, your carboxylic acid reacted with PCl3, same. Okay, your byproducts only will change here, but the main product will be same. So again, thionyl chloride also it will be same. But in this case, you can see the byproducts obtained are both gases, and they can be easily they will easily escape it out. And what will happen? Whatever the product form, it will be in more quantity. Okay, so these are the three reactions where you can obtain. Okay, you can obtain the acyl chlorides. Okay, you can obtain acyl chlorides. So hydroxyl group of the carboxylic acids, they are replaced with chlorine atom. Okay. So reaction with ammonia. Okay, reaction with ammonia. So carboxylic acid, they react with ammonia to give you ammonium salt, which on further heating with high temperature will give you amides. Okay, very important. So we have here the reaction. Okay, so phthalic acid is there here. Okay, so we are going to react it with ammonia. Okay, we are going to react it with ammonia. What I'm going to happen here? So your hydrogens, okay, will be replaced by the NH4 plus ammonium phthalate. Okay, ammonium phthalate. If you heat it, okay, what will happen? Water molecules will be lost, and you are going to get a phthalimide. This phthalimide, when you heat it, there will be loss of ammonia, and you are going to get a phthalimide. Okay, so phthalimide, and this is phthalimide. Okay, so this is the reaction with ammonia. So here also you can see this is acid. Okay, so this is your acetic acid. So this acetic acid, you are going to heat with ammonia. So what will happen? H will be replaced by your ammonium. So ammonium acetate. Okay, and when you heat it, you are going to get acetamide. Okay, you are going to get a acetamide. Is it clear? Yes. So very, very important. Ammonia reaction with ammonia is very, very important. Acidification reaction is also very, very important. So these two reactions you need to remember. Okay, from this part. Okay. Next, reduction. Next is reduction. Okay, carboxylic acids are reduced to primary alcohols by using lithium aluminum hydride or with a diborane. So you can see carboxylic acids are there. We are using lithium aluminum hydride followed by acid hydrolysis. You are going to get what? Primary alcohol. Similarly, you can use diborane also. You will get primary alcohol. So you can reduce, you can do reduction, addition of hydrogen. Decarboxylation means removal of removal of carbon dioxide. Okay, decarboxylation means removal of carbon dioxide. So I'm going to take this sodium salt of carboxylic acid. Okay, they are going to heat it with sodamine. What is soda lime? When sodium hydroxide and calcium hydroxide is taken in the ratio of 3:1. So 3:1 ratio is taken. So that is called as a soda lime. You get what? You get hydrocarbons. Okay. And there is a release of your carbon dioxide gas. So this is called as decarboxylation. So this is also very, very important. 2 marks question. Okay, mark this as important. Very, very important. So sodium salt of carboxylic acid, they are heated with soda lime. Soda lime means sodium hydroxide plus calcium oxide, 3:1 ratio. Okay, what they lose? They lose a mole of carbon dioxide and it form hydrocarbon. So this reaction is called as decarboxylation. Okay, this reaction is called as decarboxylation. Yes. Next is halogenation. So halogenation, what we are doing? Helmholtz-Zelinsky reaction, very, very important. Mark this also important. Helmholtz-Zelinsky reaction. So what is happening here? So carboxylic acid, which is having alpha hydrogen. Okay, it is good. We are going to treat it with any of the halogen. Okay, we can take any halogen, or you can take Cl2 or Br2, and in the presence of red phosphorus, okay, you're going to get alpha halocarboxylic acid. So this is alpha halocarboxylic acid. Okay, and this is called as Helmholtz-Zelinsky reaction. It is called as a Helmholtz-Zelinsky reaction. So if I take R as CH3, so it will be CH3, CH2, COH. Okay, in the presence of, I'll take Cl2 in the presence of red phosphorus. Okay, followed by acid hydrolysis. What I am going to get? I am going to get Cl, CH2, COH. Okay, so what is that? I'm going to get chloroacetic acid. I'm going to get chloroacetic acid. Is it clear? Okay. Next, we are going to get the aromatic substitution reaction, electrophilic. So you can see aromatic carboxylic acid, they undergo electrophilic substitution reaction. Okay. And this carboxylic group, it acts as a deactivating and it is a meta-directed. Okay. So it will not undergo Friedel-Crafts reaction. Okay. So we are going to do first the nitration. So for nitration, which is the nitrating agent, HNO3 and H2SO4. So the nitronium ion is generated. This nitronium ion, it is meta-direct. Okay, similarly, benzoic acid. Okay, we are doing bromination. Okay, so here the bromine Br plus is the electrophile and it will be direct at the meta position. Is it clear? Yes. So last part, what are the uses of this carboxylic acid? Hexene dioic acid is used in the manufacture of nylon 66. Then esters of benzoic acid, they are used in perfume because esters are sweet smelling. Okay, you get a very good smell of these esters. Esters, they smell very, very nice. So because they are having this unique property, they can be used in preparation of the perfumes. Then sodium benzoate, it is used as food preservative. Okay, so that your food does not get spoiled, it is used as a preservative. What is that? Sodium benzoate. Then higher fatty acids are used for manufacture of soaps and detergents. So the fatty acids, the higher fatty acids, they are used for manufacture, so for preparation of the soaps and detergent. Is it clear? So yes, so this completes your chapter aldehydes, ketones and carboxylic acid. Okay. So in today's session, we have completed about the carboxylic acid. So any doubts up to here? Yes. Anything you have to ask? Any doubts up to here? So we have completed this chapter. Okay, we have completed this chapter, aldehydes, ketones, and carboxylic acid. So today we have seen about carboxylic acid. Okay. Yes. Any doubts? If you have any doubts, you can drop the message in the chat box. Okay. If you have any doubts, you can text there.